Welcome to my YouTube channel. Dhanesh here. Today I am going to discuss about artificial neural networks. See, artificial neural network is a computing system inspired by biological neural network. You know, our brain consists of trillions of neurons, and each neuron interact with other neurons as well. It's a complex organ in our body. So this neural artificial neural networks is also inspired by the biological neural network of human beings. So to cover this artificial neural network, this section, mainly in this section, I am going to discuss mainly 7 aspects of neural networks, artificial neural networks. First one is the model architecture. What is the architecture of a neural network? The second part, it is the mathematical representation of this model. The third part, it is the activation function. Fourth one, bias node. Then fifth one, cost function or error function. Sixth one, forward propagation algorithm. And the seventh one, backward propagation algorithm. In this video, I am going to cover about the model architecture. When we talk about the architecture, this artificial neural networks, see, you can see the circles. It's represented by red, blue, green and black circles. Those circles we can call it as nodes. The first layer, the circles which represents the red circles, that is known as the input layer. You can see it, input layer. The second layer, it is blue in color. Those circles which represents it is blue in color, that is the hidden layer 1, the first hidden layer 1. So there are 2 hidden layers in this simple architecture. It's the simplest one I have drawn. The second layer is hidden layer 2, and the last circle, it's a black color, and that is the output layer. So it's having an input layer, then the hidden layers. Hidden layers can be any number of hidden layers. Here I am showing 2 hidden layers, hidden layer 1 and hidden layer 2, and the last one, the last circle, the black circle, represents the output layer. And these circles are connected by arrows. So these arrows represents the weight. See, these arrows represents the weight here. So I can tell you the black arrows represents weight of the network. See, weight of the network, if you in a most fundamental way, I can tell you, for a simple linear regression line, the equation of a line, I can write it as y is equal to mx plus c. In this equation, in the most fundamental way, here m is the weight and c is the bias. So this is the simplest explanation for weight and bias. If you are considering this y is equal to mx plus z, it's the equation of a straight line. You know that m is the slope of the line and c is the y-intercept. So for a neural network, this m represents the weight. M is the weight of the network, and c, the y-intercept, c represents the bias of the network. C is the bias. So this is the bias. Now coming back to the input layer. So input layer, when we talk about there are 3 types of layers. One is the input layer, the second one is the hidden layer, third one is the output layer. Input layer is the initial data, the data we are supplying to the neural network through this input layer. In the hidden layer, that is the intermediate layer between the input layer and the output layer, and the place where all the computation is happening. All the calculations is happening in these hidden layers. So the hidden layer is the intermediate layer between the input layer and the output layer. There all computation or calculation is happening. So when we talk about the hidden layer, main function of the hidden layer is computation or the calculation. That's what happening in the hidden layer. The output layer produce the result for given inputs. So the input layer, hidden layer, and the output layer. Output layer, it produce the results for the given inputs. So this is the architecture of the neural network. So I can give more clarity on this. For that, I can show you, this is our picture. This is the architecture. Input layer is there, hidden layer is there, output layer is there. Now input layer, normally input layer can be represented as input layer means in mathematical terms, input layer means it is the input x. X gives the input. Hidden layer, it is hidden layer. It mainly represents the weight of the network, that is activation nodes. Hidden layer, we call it as the activation nodes. Hidden layer means it is activation nodes. There we will, activation nodes means the weight of the network. The weight of the network, normally it is denoted by the letters W or theta. Theta, it's the Greek letter. So input layer is represented by the letter X. Hidden layer, we call it as the activation nodes. And here mainly the weight of the network comes. The weight is denoted by W or theta. Output layer denotes the predicted value. Output layer means it is denoted by the output layer means it is the predicted value. Predicted value is denoted by, it is denoted by Y. So predicted value is represented by Y. So input layer, it is represented by X. Hidden layer, we call it as the activation nodes. There the more focus is on the weight of the network. Weight is denoted by W or theta. Output layer, it is the predicted value, and it is denoted by Y. So all these things we understood. Now let us get into, see in this figure. If you see this figure, the circles, each circle represents the node. Each node is connected with the next node in the next layer by an arrow. In this figure you can see the circles. Each circle represents the node, and these circles are connected each other by black arrows. And each black arrow has a particular weight. You need to understand this circles denotes the nodes. Very important. Each circle represents the nodes in the neural network, and each nodes are connected by black arrows, and this black arrow, each black arrow has a specific weight. Black arrow in this our figure, it is having a specific weight. Weight is denoted by a theta or W. So weight is denoted by the letter, Greek letter theta. The circles represents the nodes. Black arrows represents the weight of the network. So weight, I have given an idea in the simplest way. I can write it as y is equal to mx plus c, where m is the weight of the network. So if you want more clarity on weight, weight is the impact of one node on the next node in the next layer. See, if you see what is the weight, see each arrow represents a specific weight. So this black arrow in this figure, so the weight is the weight of this arrow. This arrow, if we talk here, this arrow represents the impact of the one node on the next node. This first arrow represents that weight represents the impact of this red color node towards the blue node. This blue node is in the next layer. It is in the hidden layer. So that's what I am telling you. Weight is the impact of one node on the other node in the next layer. So that is the meaning of weight. So what is the meaning of weight? Weight is the very important. Weight is the impact of one node on the other node. That is very important. Weight is the impact of one node on the other node. This is really very important to understand the neural networks. So we need to, some concepts are there in this neural network. So for understanding these fundamentals must be strong. So weight is the impact of one node on the other node. The next node can be in the other layer, in the hidden layer. The hidden layers can be layer 1, layer 2, layer 3, like that it goes on. So that is the concept of the weight. Now what I am going to tell you is I am showing one node. See, one node means one circle. See, in this one node, if you analyze, this is what you will get. In a node, you will get different inputs from the previous node. At the same time, the weights also there. Weights means the black arrow. Am I right? So the inputs, for example, in this figure, if you take this first blue node, so it's having different inputs it's getting from the red nodes. Am I right? So different inputs are getting from the red nodes. At the same time, the black arrows, it's giving the weight for this blue node, the first blue node. So considering I am considering the first blue node. For that alone, I am drawing the architecture, that is this. So you can understand it is having different inputs from the input layer, at the same time different weights from the different previous nodes as well. You can see the figure. It's very simple. See, this is the blue node. It is getting inputs from the input layer. At the same time, it is getting weights. This black arrows represents the weights from the previous nodes as well. So comparing these two aspects, see, we have the inputs. This is x1, x2, x3. This one represents the bias. See, the inputs can be x1, x2, x3, and it can be bias as well. I have told you y is equal to mx plus c. There c represents the bias. C is the y-intercept that represents the bias of the network. So this one represents the bias. So you have x1. So the inputs can be the input x1, the variable x1 or x, and the bias can be the inputs. Then we need to apply the weights. Weights are W1, W2, W3, W4. So weights represents the black arrows. That is the weights. So all these things, the weighted sum, it is represented by the letter sigma here. The weighted sum is coming here. And this weighted sum is modified by an activation function, and we will get the output here. See, this is the output coming from this blue node. Is after the activation function, it will give the output. So what is this? This is the process. It's happening in a single node. It's having the inputs, then the weights, then the weighted sum. It is represented by the letter sigma, and the weighted sum is, undergone some changes. See, activation function means in neural networks, the activation function defines whether the given node should be activated or not based on the weighted sum. So this is what activation function, do. So more clarity we will get in the next. See, this is the first part, the general architecture only we are doing. So the activation function in a neural network, the activation function defines whether the given node should be activated or not based on the weighted sum. See, based on the weighted sum, the given node, the next node will be activated or not. That's what it determines here. See, the next node is the green node here. So whether that should be activated or not, but that depends on the output from this blue node, right? So that is determined by the activation function. So what is the role of the activation function? So you need to understand the activation function defines whether the given node should be activated, whether the given node should be activated or not. The given node should be activated or not. So the given node should be activated or not based on the weighted sum. It is based on the weighted sum. This is what an activation function does. So in a neural network, the activation function defines whether the given node should be activated or not based on the weighted sum. See, commonly used activation functions are, I can tell you the commonly used activation functions in neural networks. The commonly used activation functions are we use step function. This is the first one. Step function we will use. Second one is ReLU. Rectified linear unit. This we call it as this is a linear function, a straight line. This is y is equal to mx plus c. This we call it as the rectified linear unit. This is another one. Third one I can tell you is the sigmoid function. These are all important. We will discuss. Most commonly used is sigmoid function in neural networks. Sigmoid function is the most commonly used, very important. Sigmoid function, it is the most commonly used function in neural networks. It's important. And another one, activation function we usually use, it is hyperbolic tan. Tan, right? Trigonometric functions, sine, cos, tan. So hyperbolic tan is another one we usually use. The most commonly used activation function is this sigmoid function. This is the most SIGMOID sigmoid function. So these are all the four types of activation functions we use it in artificial neural networks: step function, ReLU function, sigmoid function, hyperbolic tan. So these are all the activation functions we use. See, step function linear this ReLU means linear function. It is represented by y is equal to mx plus b, and sigmoid function means it is denoted by the letter sigmoid function sx is I can tell you it is the most commonly used. You call it as the Sx. I can write it like this: Sx is equal to the sigmoid function is given by 1 by 1 plus e raised to minus x. This is most commonly used activation function in artificial neural networks. See, in more detail about these activation functions we will discuss later. See, this is the architecture of the neural network. Still we have to cover a lot of things based on this neural networks. This is the architecture, then the mathematical representation of this architecture, then in-depth activation function, what are all the common types of activation functions and how it works. Those things we need to discuss. Bias node, cost function, the forward propagation algorithm, backward propagation algorithm. So all these things again we need to discuss. In this case, we cover only the model architecture, only this part we covered. Only in this video whatever we covered is the model architecture. See, again 6 more sections we have to understand. So you understood the activation function. Once again I am repeating, in a neural network the activation function defines whether the given node should be activated or not based on the weighted sum. Commonly used activation functions are step function, ReLU means rectified linear unit, sigmoid function, hyperbolic tan. So this is the architecture of the neural network we discussed. It consists of input layer and the hidden layers. Inside the hidden layers, the calculations, the computations, everything happening inside the hidden layer. The output layer, it gives the output. The input layer gives the input layer. It is given by the letter x, right? So input layer, you have the x. Then the hidden layer, there are multiple hidden layers can be possible. So all these things we discussed. So that's all about the architecture of the neural network. Thanks for watching.